Okay, it's been a quiet couple of months. Things sort of slowed down a bit leading into Christmas, and then obviously after Christmas, and then getting the trades back. And even if I could get the trades back, for example, we had the glass sitting in the factory with the factory closed down for a month, and we were ready to put the glass in, but we finally got that east facade of the glass in, so the building's at lock-up now. So what that also means is it's watertight, and then we've been able to finalise it, getting it airtight. We finally got a plastering contractor, so got that plaster in as well, and it has been going a little bit slowly. You know, it took about a week and a half, 2 weeks at least to get the plaster in, and effectively it's 2 internal rooms. Sorry, 3 internal rooms, which should, you know, you should be finished that within a week, I guess, but because getting the plaster up through the floors as well was hard, cutting everything down to size and getting it through just added to the degree of difficulty. Everything with this build has been sequencing as well, and then things going much more slowly because it's a new process and way of building, I think, for a lot of the contractors as well, from the electricians to the plumbers and so on. Everything had to be premeditated for the airtight barriers going in, because you only had one go at it. You couldn't move anything after, you know, just punch a hole in the plaster and move something, because there's an airtight barrier behind there which could get damaged. So everything had to be methodically sort of thought of prior to installation. So now that the floors and so on are going in, also the stairs have gone in, and that's really changed how we're using the space in the building as well, because we can't walk from the outside in because that east facade now is closed off. So it's really changed the feel of the space as well. What we're also in the process of doing, and what we started doing, is that is the testing for the airtight factor of the building. We're aiming for that European standard of getting the building airtight. Then we can use the ventilation systems. The heating and cooling systems run more efficiently, which are running through that ventilation system. So we have less heat loss off the air, and we're getting fresh air into the building as well. So through this part, we've hit approximately air permeability number of 6. To give it a bit of perspective, the UK standard's 10, so we're already below that, and we're aiming for a lot lower. I think we'll get to around, you know, 4.5 or so. That's what I'm sort of aiming at. You know, the Germans are down at 0.5, 0.6, so there's a huge sort of difference, but their whole building system is oriented around this system. I think we haven't got our heads around it here yet with the design aspect of it. It really needs to be part of that design process to do that and achieve that easily. Part of the window systems, part of the door systems, and for example, the front facade, for example, we had to work quite hard at getting that airtight because the system wasn't based around an airtight system. It's completely up to the Australian standards, but the Australian standards are nowhere near at what they are around the world as far as getting the building airtight. It's not a requirement. So we're really pushing that envelope, and I think that's the future. We need to do that because you can have a really efficient air conditioning system or a heating system, but if it needs to work longer and harder, it's actually not that efficient in the bigger picture. And this is what this whole project's about, looking at the whole picture and each system supporting each other. So the start of this was getting that airtight house, or getting it as tight as possible, and then the rest of the systems work more efficiently and support each other. Part of the cabinetry philosophy here is utilising every part of the space in the house. So from under the stairs to under the planter boxes, we've got drawers that tuck in under the planter boxes on the west facade, and utilising all that area behind there. We also have ducting running behind that. Everything is crammed in the space, but that gives us more storage and more sensor space. As far as the materials we're using for the cabinetry, we're actually using plywood. And that was a decision made because plywood has a lower embodied energy than particle board, and MDF obviously has formaldehyde and their glues and so on. So even the ply that we're using is a low to zero formaldehyde sort of ply. So we're looking and drilling down to every aspect. And look, there are going to be instances that we can't use anything other than a product that has some of these elements in it, but we're reducing it. And if we keep pushing for that, as I mentioned, previously, there are products available around the world, but they're not in demand here because they're not being used. But if the demand grows, the product will be available, and we'll be able to use that. And it's taking all the right steps. So.